All right, this is our only video on histograms. So histograms are, and our goal will be to use histograms to analyze data. Histograms are a special kind of bar graphs. So when you look at this graph right here, we know that's a bar graph, and we've used bar graphs a lot. In fact, I had some to share some data with you recently. So when we look at a bar graph, it really helps us to identify the mode of your data. But bar graph lists data in categories. A histogram is a special kind of bar graph. I'm going to zoom in on this so you can see the book definition here. So it's a special kind of bar graph that shows the frequency of data values in intervals of the same size. So you can see the height of the bar represents the frequency of the values in the interval. So for example, if I collected this data asking a bunch of adults how many CDs they owned, because you guys probably wouldn't own a lot of CDs. And if I asked them that, you might have some small answers, from 0 to 9. People might say 6 or 3 or 8. Those all fall into that interval. And that way I can combine that data rather than having a bar graph, which would just show me every different answer, and it might not really help me. This kind of summarizes it in equal groups. So when you make a histogram, this is kind of the process you would follow. So this frequency table shows me how many laps different people completed. So 11 times someone completed 1 to 3 laps in a swimming pool, 4 times 4 to 6 laps, and so on. And so the frequency is how many times somebody answered the question. So there were 11 people that answered 1 to 3. That's why that bar is so tall. So you can see that that's where most of the laps were. A lot of people only did 1 to 3 laps. I'm real impressed with people doing 13 to 15 laps. They've got good heart healthy and their lungs are solid, and they're good swimmers to do so many laps comparatively. Note that you would include an interval even if there's no frequency for that interval. So that empty space is important. It alerts us that there's space there. And in fact, you'll notice that that's kind of a big difference between a standard bar graph and a histogram. Is a histogram, the bars touch each other. They lean against each other. And that's because of that growing nature of a histogram. It kind of combines that data. So when you make a histogram, there are some components that I think make it a good histogram that I would like you to follow if you're ever making a histogram. It's hard to show when we're working with the items I printed from my computer printer because it's a black and white printer, so I don't have color pictures to show you. But generally, when you make your histogram, you want to have alternating colors. Not every histogram I'm going to show you today has alternating colors because it's not a requirement. It just makes it easier to read, and that's a recommendation. But generally, you want a title that's easy to understand. Your subtitles let you know what it is that the graph is about. But the bars should all be the same thickness and should be either different colors or they should alternate colors. And then they would always be in equal intervals and lean against each other. So when you look at these two graphs, you can see that this shows how a histogram and a bar graph looks very different. This is in intervals. You can't really do intervals with countries, so you would have to do bar graph. But with intervals, you would use a histogram. So which of these is a histogram? There's my first question. And it should be pretty obvious to you that this is a histogram. Even though there's this space, it just indicates there's no data there. All right, but there's still a category, and that's what lets me know that this is the histogram. This is showing data in categories, and it's got spaces in between because that's appropriate for a bar graph. Keep in mind a histogram is a type of bar graph. It's got a special nature to it. It asks me to describe the outliers in the histogram. So the outliers would be data that's far from where the data cluster. So when I look at this example, which is my histogram, my data cluster is here, which means everything that was answered here is an outlier. Even if there's more than one, it's far from where the data clusters. So it looks like there's a couple students who did really poorly on their test, and they stand out as being different than where the data clusters. So how can you tell when an interval of a histogram has a frequency of 0? Well, that's easy. If it's got no bar, that would let me know that there's a frequency of 0. So this is some real data of winning speeds at the Daytona 500. And you can see that as they cross the finish line, their winning speeds varied significantly. I guess in different years, depending on weather conditions, etc., the winning speeds were lower. But you could see the most common winning speed was between 150 and 159 miles per hour. Now, what's interesting with a histogram is you can answer questions that maybe aren't as obvious, like how many cars had speeds less than 140 miles an hour? So I can see that this bar is clearly less than 140 miles per hour. There's 4 cars that did that. Okay, but then there's another 1 car here. I'm going to do my darker pen here because it's a little hard to read. So this clearly shows 1 and this shows 4, which means there's a total of 5 cars that had less than 140 miles an hour. So you've got to understand, sometimes we ask questions in a histogram where we have to kind of combine our data to answer the question. So we're going to do a couple questions like that with this. So this is a histogram that shows the number of hours that students in a class slept last night. So last night, how many students slept at least 8 hours? And so you can see that this bar is students that slept from 8 to 11 hours. A lot of good sleep for them. But wait a minute. This bar is those extra heavy sleepers that slept even longer. That's still at least 8 hours. So I sometimes, when I'm reading a histogram, just to make it easy to answer questions, I label what the value is just on my own paper. So 2 people slept from 0 to 3, okay? And 8 people slept from 4 to 7. And 8 people slept from 8 to 11, and then it looks like 3 people, because you can see this is directly between the 2 and the 4, slept at the 12 to 15 hours. So what I can do is I can add up this bar and this bar to find that 11 students slept less than 12 hours. 11 students. All right? Very good. And slept at least 8 hours. Then it said how many students slept less than 12 hours. That would be this bar, and this bar. That would be 18 students. So there were 11 that slept at least 8, and then there was 8, 16, 18 that slept less than 12. So here's another histogram. And when I printed this, it was in all different colors, but now you really can't tell. But I can, again, real quick, read the data and understand that it looks to me like 3 students did 0 to 9 push-ups, 5 students did 10 to 19, 10 students did 20 to 29, 6 students did 30 to 39, and it looks like this comes out to be 1 student that did 40 to 49. And so who knows, maybe they were given a minute or a minute and a half to do as many push-ups as they can, and this was the results. So the first question I have is, how many students participated? How many students participated in this? And in order to answer that question, I'm gonna add up all these numbers. So 3 and 5 is 8, plus 10 is 18, plus 6 is 24, plus 1 is 25. So that's how I can answer that question. Now my next question is, how many students completed exactly 22 push-ups? Now that's an answer I can't answer with this graph. One of the drawbacks of a histogram is it doesn't show the raw data because it's combining things. And so I know that anybody who did 22 push-ups would be in this bar, but I just don't know how many. Now the last question is, how many students completed more than 19 push-ups? Now that I can figure out because I can see that more than 19 is this bar, and this bar. And I can add those up because 10 plus 6 plus 1 is 17. And so that means that there were 17 students who completed more than 19 push-ups. All right, and so here's another histogram, and it shows magazines, and it says, the histogram shows the number of magazines read last month by the students in a class. Which interval contains the fewest data values? That should be obvious. There's no data in the 4 to 5 range, so that's the one that contains the fewest. How many students are in the class? Now, this would be another good opportunity to kind of count up. Now, I mentioned earlier, I don't think it's a good idea to count by 3s in a graph, and it's because, man, it is hard to tell what that means. But it looks like 2 students read either 0 or 1 magazine. It looks like 15 students read 2 or 3 magazines. We know no students read 4 or 5, and 3 students read 6 or 7. I certainly would have counted either by by ones or twos here, but counting by threes makes this graph a little bit hard to read. All right, so now I can answer the question, how many students are in the class? And according to this, it's 2 plus 15 plus 3, which means there are 20 students in the class. What percent of the students read less than 6 magazines? So what I can do is, since the people who read 6 or more is 3 students, that tells me that it's 17 out of 20 students read less than 6 magazines. So what I can do is I can make that into an equivalent fraction over 100, since this times 5 equals 100 and this times 5 equals 85. That tells me that 85% of the students read less than 6 magazines. And then finally, can you find the mean or the median of the data? And no, we just can't. We don't have the raw data. Again, that's one of the drawbacks of a histogram. We can't answer that question because we don't know the raw data from which this graph was made. All right, last question. This data shows how many pounds of garbage apartment residents produced in 1 week. Which data display can you use to find out how many residents produced more than 25 pounds of garbage? You can't get that data from here, but you can here. And so even though stem and leaf plots are way easier to make, a lot of times they can be more helpful in looking at data because the raw data is shown. So that's a good reason to consider stem and leaf plots when trying to organize your data. All right, that's the end of our video on histograms. Thanks for sticking around until the end.